Okay, this is video number 6 in our Jefferson Flats series. You can see in this drawing I've already got my pipes and structures installed here, but I used just a dummy pipe. I used just 12-inch concrete pipe for all of this network, and it's probably the case that 12-inch pipe is not going to be large enough to carry all the water off of this site, especially once we get further downstream in our network here. So how do we know what size pipe to use? A couple of different methods. There's built-in pipe calculators in some versions of AutoCAD. There's online pipe calculators. You can crank on the numbers yourself if you choose to do that, but I took Excel and just built my own pipe sizing calculator here, so I can show you how I put this one together in a different video maybe, but for right now I'm just going to use this calculator for figuring out pipe sizing in my drawing. So you can see I've got sort of a from and to structure starting this calculator. So again, we're talking about the pipes, so I thought it was appropriate to say from one structure to another structure is that connecting pipe. And then we will input the catchment area or contributing area, everything flowing into a catch basin structure. So that's one of the inputs I'll have to input here. I'll also have to input my C value for runoff, and then we'll use a 10-year 24-hour intensity, so we'll have to look at an intensity curve. We will have to input some pipe length, and I don't have any pipe slopes yet. I haven't done any vertical design on this pipe network, so I'm going to use a default pipe slope of, let's say, 0.5%. So I can input that now. I'll just say this is whatever we're doing for right now. I'll just input 0.5%. Also for right now, we're going to start with a 12-inch pipe diameter, so I'll drag that down. And then we are going to be using concrete pipe in this project. So if I look at a table of N values here for concrete pipe, I get 0.013. So I'll put that in 0.013, and I can drag this down to auto-populate. And then if I scroll over, the payout comes at the very end. Are we meeting the design? And that design, I've just decided to go with a 95% maximum capacity. We don't want to go over 95% at any time in our pipe. So if we trigger something over 95%, this will turn into a red no. But if I come back here, there's a few other things that I can put in right now. So this intensity, if I look at an intensity curve for where I am, I'm going to use a 4.1 inches per hour based on the intensity maps locally, and I'll just drag that down to auto-populate. And then if I look at a C value table, pretty much everything that I'm going to look at in this drawing is going to happen on a asphalt pavement. So I'm probably going to use this 0.95 as a default, just to be on the safe side. So I'll use that 0.95. In other parts of my network, I may have some grassy areas or some mixed use. So you'll have to look at your land use or your ground cover and figure out what C value or composite C value you're going to use. Now that I have some of the basic inputs, I can start looking at my network, and I'm going to start at sort of the furthest point out in my network. This whole portion of my network flows towards the west, so this is kind of the furthest point away. So I could say from structure E to structure F. And what I need to look at then is the contributing area for this structure E, right? How much water is flowing through this pipe? And the water that flows through this pipe is the water that falls into catch basin E. And I need to know that contributing area, so if I need to zoom out so I can pick this polyline. So here is the closed polyline that represents the catchment area for catch basin E, and all of that water is going to fall in here, so I need to know what that area is, and it looks like 50,883, we'll call it, I'll round up, 50,883. So in my spreadsheet I can say 50,883. And then when I input that, some of these will start auto-populating these grayed out cells, and then I'll just come over to the next sort of input columns, and I'll put in the pipe length first. I'm going to leave this red column alone for a second. So what is the pipe length from structure E to structure F? So if I look at this pipe length, I shut off the layer with my polylines connecting these structures, but I can still select the pipe, right click, and look at the pipe properties. And if I look at the part properties, I should have a pipe length. So 2D pipe length, about 47 feet. So I'm going to say, and I can see that right here, 2D and 3D length. So I'm looking at the 3D length, center to center, that's 47 feet of pipe. So I'll say OK, and I will input 47 feet. And looks like so far so good. Now the only column I have left to input is this column J, total design discharge. This is the column that I really have to think about, and it's saying what is the total amount of water flowing downstream from this pipe, or what is the water traveling through this pipe. Well, for this particular pipe, it is only the water that we caught in this area that falls into catch basin E. So I can look at this column I is my Q, or the quantity of flow, and right now that's saying 4.588 cubic feet per second flowing through that single pipe. And now when I input into column J, it looks like no, 12-inch pipe is not enough to carry all that flow because it's such a large contributing area. So here my percentage capacity is over 95%, and that means I need to increase that pipe size. So I'll go from 12 to 15 inches, and now I'm down to 92.5%, so that is going to give me a pass. So I'll come back, and now I will look at the next pipe in our network that I'm going to input into my calculator is from F to D. So from structure F to structure D, and what is the contributing area? So what is the area that catches water that will flow into catch basin F? So if I select this polyline, this will show me the contributing area. I've already analyzed the surface. So if I look at the properties for that area, I'm looking at 6,050 square feet approximately, 6050. So I will put in 6050. And what is my pipe length from F to D? So again, I can select that pipe and look at the pipe properties. And if I scroll down to my 3D length, I'm looking at 31.64. So I'll input 31.64 feet. And the last thing I need to do is input this column J, total design discharge. Now, again, that's asking what is the total amount of water flowing through this pipe from F to D? Well, it is all of the water we caught in catch basin F, plus all of the water that we caught in catch basin E. So we're going to start adding these things up as we move downstream. So here's all the water we caught in catch basin E, our first catch basin. And here's the water that we caught in catch basin F. And the total flowing downstream from F is going to be both of these numbers combined. So if I get my calculator out here and I say 4.588 plus 0.545, so I'm adding these two numbers together, I am going to get 5.133 cubic feet per second. And let's see if that pipe is big enough. I'm guessing no, because 12 inches wasn't big enough for the first pipe, so we're likely going to have to step that up a little bit. And 161%, yes, we are going to have to move that up. So I'll go in here to my pipe diameter, and I will change that to 15 inch for that pipe, and let's see what happens. I'm still over 95%. I'm at 103.5%. So now I need to move that up, let's say, to 18 inches. And at 18 inches now, I am back within my tolerance for capacity. So going to do a couple more of these. Now I'm looking at the pipe from C to D. I'm gonna wait on this pipe. I'm gonna wait to do the downstream pipes and want to get these upstream pipes first. So the next pipe I need to look at connects C to D. So I'm going to input that here. Pipe C goes to pipe D. Or I'm sorry, structure C flows into structure D. And what is the contributing area for structure C? Or how much water is going to fall into this structure C? So here's my catchment area. If I look at the properties for that, 17,216 approximately. So 17,002, we'll call it 17,217, just round it up a little bit to be safe. And then again, the pipe length between C and D. So what is the length of this pipe? I will go to the pipe properties and scroll down to 3D length and 58.13 feet. So 58.13 feet. And then I have to look at this total discharge again. So how much water flows from C to D? Well, in this case, it's only the water that we catch in catch basin C. So that is, here's my Q, or my quantity, in catch basin C. And there's nothing else we need to add to that right now, so I'm going to say 1.552 cubic feet per second. And now let's go over here, and yes, I get a pass. We are only at not even 50% capacity for that pipe because it's such a small area flowing in here. But as we get to our next section of pipe, this is flowing from D to G. So let me come back over here, from D to G. And now we have to look again at the contributing area. So if I look at the contributing area for catch basin D, it's kind of a strange shape, but it's not very big, and I'll go to the properties, and it's about 5,700, just over 5,700 square feet. So go 5701 just to be safe. And what is that length of pipe from D to G? So what is the length of this pipe if I look at the pipe properties? 3D length is 212.16. So 212.16. Now I have to think about what is the total quantity flowing through this pipe. Well, I have everything that we caught in E, everything that we caught in F, everything we caught in C, and now everything we caught in D. So I'm going to have to add all of those quantities together in this this red column here. So everything we caught in E is this first pipe. Then everything that we caught in F will be the next line down. Everything we caught in C and everything we caught in D. So all four of those quantities are going to get added together for this next cell. So if I add all this up, 4.588 plus 0.545 plus 1.552 plus 0.514. So our total Q flowing through that pipe is 8.199. And now let's see how big our pipe needs to be to accommodate. So I'll scroll over here and we should see a fail. Yep, 258% capacity at 12 inches. So I'll start increasing this. 15-inch would be the next size pipe. Still not big enough. How about an 18-inch pipe? Still not big enough. Let's go to a 21. And at a 21-inch pipe, finally we get a pass here, back to 85% capacity. You may want to use a different pipe calculator. It does take a little bit of effort to build one like this, but I find it's pretty handy for sizing your network. Again, you just have to be careful about thinking really how much water is flowing through each pipe. Some pipes only have a little bit of water. Some pipes are going to carry water for that whole system. So eventually, by the time we get down here, we might be looking at a 36-inch pipe or bigger. So I will complete my calculations, and then once I have my pipe calculator completed, then I can start going back and saying this pipe needs to be swapped for a larger part. And we'll cover that in a different video.